object can have energy even when it is not moving. So when the object is moving, it has kinetic energy. But an object can also have energy even if it is at rest. And this energy is also called stored energy based on the object's shape or position. So this is called potential energy. Okay? So potential energy is the energy that is stored based on the object's shape or position. Okay? Or we can say that an object that is at rest has potential energy. What are the forms of potential energy? Chemical, nuclear, mechanical, electrical. So these are forms of potential energy. Now, what factors affect potential energy? Since this energy is stored or held in readiness. Like, for instance, the book on your desk, mango hanging from a tree. So these are examples of potential energy, energy that is stored or held in readiness. Okay? Pulling back a rubber band. So these are examples of potential energy. So if the mango stays in the tree, it will keep the stored energy due to its height above the ground. So if the mango falls, that stored energy of position is converted to energy of motion to prove that when the mango is hanging, it has stored energy. This stored energy is converted to energy of motion as it falls. So these are the types of potential energy: gravitational potential energy, elastic potential energy, chemical potential energy, and electric potential energy. Gravitational potential energy, or GPE, is the potential energy related to an object's position above the Earth's surface. Like, for instance, lifting your book on top of your desk. You do work when you lift it, because when you lift the book on the top of your desk, you moved the object, so there was height, and you exerted force to the object equivalent to its weight. So whenever there is force and there is height or distance, work is done. So there are two factors that affect gravitational potential energy: weight and height. So gravitational potential energy increases as weight and height increase. Have you ever been to Enchanted Kingdom or Star City? So these two amusement park provide a very exciting ride, which is the Jungle Log and the Wild River. So because of the gravitational potential energy stored at the top of the path, or the ray, or the path of the moving log, the potential energy at the top makes the ride fun, because the potential energy, the gravitational potential energy at the top, is converted to kinetic energy as the log moves down. Same as with the Wild River. Okay? So these two rides we enjoy because of gravitational potential energy. Now let us proceed to the equation for gravitational potential energy. So gravitational potential energy is equivalent to mgh. Okay? So on Earth, the acceleration of gravity is 9.8 meter per second squared, and the symbol is g. Okay? So since you multiply mass, which is a unit of kilogram, acceleration due to gravity, meter per second squared, and height in meter, you will have a unit of kilogram meter squared per second squared, which is also equivalent to joule. Okay? So the formula for gravitational potential energy is mgh. However, there is another equation for GPE. Since GPE is equivalent to mgh, we know that mg is equivalent to weight. When we multiply our mass with the acceleration due to gravity, we are computing for our weight. So we can substitute Fg or weight or gravitational force to mg. Therefore, GPE is equivalent to Fg times height. So we have two equations for gravitational potential energy. The first equation is GPE is equivalent to mgh. And the second equation will be GPE is equivalent to F sub g times h. Okay? So how does gravitational potential energy change? So the GPE of an object can be increased by increasing the height. If the objects are at the same height, then what other factor can affect GPE? The object with a larger mass would have more gravitational pull, thus more GPE. So there are two factors that affect GPE: mass and height. And mass is associated to gravitational pull. The more mass the object has, the more gravitational pull it will have. And the more GPE the object will have, or the more gravitational potential energy it will store. Now let's have a sample problem for potential energy. Determine the gravitational potential energy of a 625 kilogram roller coaster car that is at a height of 97.5 meter. So using GRESA, the given are the mass, 625 kilogram, and the height, 97.5 meter. So to solve for GPE, so our required is GPE. The equation is GPE is equivalent to mgh. I forgot to write the equation here. So the equation is GPE is equivalent to mgh. Substituting, we have 625 kilogram times 9.8 meter per second squared, or 9.8 meter per second times 97.5 meter. The tentative answer is 597,187.5 kilogram meter squared per second squared. And the final answer is 597,187.5 joules. Now, if the roller coaster car in problem number 1 has twice its mass, then what would be its new GPE? So the given, twice the 625 kilogram is 1,250 kilogram. The height is 97.5 meter. Now, the required is GPE. The equation for GPE is equivalent to mgh. Solution, GPE is equivalent to mgh. So 1,250 kilogram times 9.8 meter per second times 97.5 meter will give you 1,100,000 194,375 kilogram meter squared per second squared, or 1,194,375 joules. So, the next type of potential energy is elastic potential energy. So, elastic potential energy is the potential energy associated with objects that can be stretched or compressed, like, for example, pulling back a rubber band and winding up a toy. So, when the rubber band is stretched, it stores energy. And this stored energy is called elastic potential energy. Next, if you let the rubber band go, it sails across the room. So as it flies through the air, it has kinetic energy due to its motion. So the kinetic energy came from the stored energy when the rubber band was stretched. So the kinetic energy was converted from elastic potential energy. Another example is chemical potential energy. So chemical potential energy is the potential energy associated with atoms that are bonded together. Example, charcoal and food. So this potential energy is released when the bonds break, okay, through burning or combustion. In case of the food, through digestion, the food breaks to release the chemical potential energy and be utilized by our bodies. Last is electric potential energy. So electric potential energy is the potential energy associated with charges at rest. One good example is the lightning. Lightning is an example of static electricity. So it has stored energy or potential energy that is released when it strikes the ground. Remember this, energy comes in many different forms. So let us enjoy the different forms of energy in our lives. I hope you learned something from our lesson today. Thank you and good day.